Today on Flipping Science we're going to look at finding the charges of ions and explaining how we got there. So we're going to look at both positive metal ions and negative non-metal ions. So the best way to do it, I think, is to start by drawing and then work our way onto the periodic table and then see if we can answer some questions from there. So we're going to start by looking at sodium. So here's sodium. I need to find it on the periodic table before I do anything else. So find sodium, here it is, number 11. So I need to put in 11 electrons. First thing I'm going to do though is I'm going to put in 11 protons in the nucleus, because that's important. Then I need to put in the 11 electrons. We start from the inside and work our way out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11. So if we look at it that way, we can see that there's 11 protons in the nucleus and 11 electrons. The 11 electrons are in 3 shells, so the electron configuration is 2.8.1. Now, when sodium forms an ion, it could either gain 7 electrons in this shell to make it stable, to give it an octet, or it could just lose 1, and that's what it does. So we get rid of that one. So now the electron configuration is 2.8. Problem is, if we count up our electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we've got 10 electrons which have a negative charge and 11 protons in the nucleus. Each proton has a positive charge, so we've got one more positive than negatives. So we've got 11 protons and only 10 electrons. So that means we've got one extra positive charge. So overall that gives a charge of +1 because we've got one extra proton in the nucleus. So when we write the charge on a sodium ion, it is going to be Na+. We don't usually write the 1, Na +1. So there's one more proton in the nucleus than there are electrons around it. Now we'll look at chlorine. So chlorine, we find it on the periodic table. Let's have a look. Over here, atomic number 17. So that means it's got 17 protons. P equals 17. So now we need to put in 17 electrons around it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So if we look at where the electrons are now, we write down the electron configuration, 2.8.7. So 2 electrons in the first shell, 8 in the second shell, 7 in the outermost shell. So when it reacts, it's going to get an extra electron in here, that will give it 8 in total. So that will make it stable. So I'll put in my extra electron. Now I need to write it out again, so 2.8.8. Problem is now, if we count up our number of electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, we've got 18 electrons but only 17 protons. So proton equals 17, electron equals 18. So each electron has a negative charge, so we've got one extra negative compared to the positive. So that gives it a charge of -1. So that's why I put the little minus up here. So this is called the chloride ion. If we can compare the chloride and the sodium ions, right? Sodium ion is called sodium ion because it's a metal. It's got a positive charge, so we just call that the name plus ion at the end. If we look at the chloride ion over here, because it's a non-metal, it's on the right-hand side of the staircase, we put iod on the end. So rather than being chlorine ion, it's just the chloride ion. So that's a rule you can follow. So on the right-hand side, it's going to be negative. Let's look at some more examples. Let's look at calcium as an example. So we find calcium on the periodic table. Over here, it's number 20. The atomic number is 20, so in the nucleus we've got 20 protons. Now we need to put in our electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 2 more, 19, 20. I'm going to put them on opposite sides. So when calcium reacts, it could either gain a whole heap of electrons in here, but more easily it's going to lose these electrons here. So its original electron configuration, 2.8.8.2, we lose these 2 electrons here, so that gives it 2.8.8. Now if we add up our protons, we've got protons is 20, our number of electrons now is 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. E minus equals 18. So now we've got 2 extra protons with a positive charge compared to electrons, so that gives it an overall charge of +2. So that makes the calcium ion +2. Do one more example before we look at the periodic table and see if we can figure it out from there. So let's look at oxygen. So oxygen, find it on the periodic table, over here, number 8. So that means we need to put 8 protons in the middle, so P equals 8. Then we need to put 8 electrons around it. So 1, 2, 3, 4, 5, 6, 7, 8. So now if we look at where the electrons are, we write down the electron configuration. So it's 2 for the first shell, 1, 2, 3, 4, 5, 6, 6 for the second shell. So when it reacts, it's going to get 2 extra electrons in here. So if I put them in there, you can see that now the electron configuration is 2.8. It's gained 2 electrons. So the number of protons is 8, the number of electrons is now 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 2 extra negative charges compared to the positive, so that gives it a charge of -2. So this is called the oxide ion. So oxide. So again, this is a non-metal, it's got a negative charge, so we put IDE on the end. It's not the oxygen ion, it's the oxide ion. Now, once we've done this a few times, we can look at the periodic table and see what the trends are going to be. So let's say I pick sulfur, for example. So I'll pick sulfur, I'll put a little box around sulfur so we can have a look at sulfur. We can look at some trends. So sulfur here, it's in group 6. What that means is if we did its electron configuration, the last number would be 6. To be stable, it wants to have 8. So it could lose 6 and go back over here, but it's not going to do that. It's going to gain 2 electrons. So if we look at sulfur, it's going to gain 2 electrons. So on a blank piece of paper, put sulfur. So we're trying to figure out what is the sulfur ion. So what's the sulfur ion? Look on the periodic table. Sulfur's got 16 protons. Right? It wants to have a stable number of electrons, so it's going to get an extra few. It's in group 6, so it wants to be up here. So if we're trying to figure out how many electrons the sulfur ion would be, we have to go 16, 17, 18. It's going to gain 2 electrons. This electron here and this electron here. And that will give it a charge of -2. So its number of electrons would be 18. Okay? So we've got 2 more electrons than we have protons, so that will give it a charge of -2. That would be called the sulfide ion. Okay? Let's look at another example. Let's look at magnesium. So what's the magnesium ion? Right, we find it on the periodic table, it's over here, it's number 12. Now, it could gain a whole heap of electrons to push it up over here and make it stable, or it could lose 2. It could lose this one and that one to get it over here to neon. Alright? So if it's losing electrons, it's going to be more stable, so it's going to lose 2 electrons. So at the moment, it's got 12 protons. The ion, though, is going to have 2 less because it's losing these electrons to make it stable. So the electron number is going to be 10. So that means it's going to have 2 extra protons than electrons, so its charge is going to be +2. And that's called the magnesium ion. Okay, so that's the process. So using the periodic table, you can figure out the charge of most of the ions. General rule is, if it's a metal, it's the group number, so +1, +2, +3. If it's a non-metal, it's the group number -8. So 7 take 8, -1. So all of these form a -1. 6 take 8, -2. So all of those form a -2. From looking on the periodic table, though, we can see what's happening. So these are gaining electrons to get them stable. These ones here are losing electrons to make them stable. The number of moves you go tells you what the charge is going to be. So that's an explanation of how you find the ion charge on different atoms on the periodic table. That's it for Flippin Science today. See ya!